So now we're going to look at some trig substitution problems. So these are integrals that normally just have like a radical or a square root into them, but you're always going to do some kind of trig substitution, and the idea is to take advantage of a trig identity. So when I have an x squared plus 1 under a radical, one of the things you want to think about is what kind of trig function, like there's a couple of identities. I have sine squared x plus cosine squared x equals 1. I also have tan squared x plus 1 is equal to secant squared x. Okay, and so whenever I have an x squared plus 1, I'm thinking like this. Like if I do x is equal to tan x, or actually, we'll use a different variable. We'll say x is equal to tan theta is usually the substitution. Then I know that this part is going to get converted into tan squared x plus 1, which will become secant squared x. And when I take the square root, it'll become secant x. So dx is going to equal to tan squared theta d theta. Secant squared theta d theta. Okay. So what you would do is you would say, well, then this integral, I'm going to replace the x with tan squared theta plus 1, and then replace dx with secant squared theta d theta, like that. Okay. Now this becomes the integral. This becomes secant squared theta. And this becomes the integral of secant cubed theta, because square root of secant squared is secant cubed. Now we have to do this integral, and this integral is a tricky one. It's actually similar to the trig. It's a trig integral back in the previous section on 1.6. So to do this one, I'm going to do a U-Substitution, integration by parts. U is equal to secant x, secant theta. dv is equal to secant squared d theta. And so v is going to be equal to tan theta. And du is equal to secant theta tan theta d theta. So then this integral becomes uv, which is secant theta tan theta, minus the integral of v du, which is secant theta tan squared theta d theta. Okay. And then, wait, is this the process? We did this integral in section 1.6 to get an answer. So you can look back up how we did this. This is number 12. I think we did this one. Yeah, number 12 in section 1.6. But it's going to give us a weird answer. I'm actually going to look up what we did on that one. I don't know why. Get stuck. So when we did this integral back on 1.6, it was tan squared secant x. We had this answer. 1/2 secant tan x minus 1/2 natural log. So then this is going to be just going through the process. Secant theta tan theta minus 1/2 secant theta tan theta minus natural 1/2 ln. Sorry, I should have just copied it from the previous one. So it'd be plus 1/2 because I'm doing a minus. So it's going to be plus 1/2 natural log of absolute value of secant theta plus tan theta plus c. So then this this minus this just becomes 1/2 secant theta tan theta plus 1/2 natural log absolute value secant theta plus tan theta plus c. Okay. So we're not done, because while we've computed the integral at this point, actually, have we finished computing the integral? Yes, we finished computing the integral. We have to convert it back into x. So everywhere there's a tan theta, it's replaced with x. But how do I handle the secant thetas? Right, so this is x here, and this is x. But how do I handle the secant theta? Well, you always draw a triangle, and you say, like, well, this is my angle theta. And I know that x is equal to tan theta. So tangent means it's opposite over adjacent. So I can do x and 1. Right, and then from this right triangle, this hypotenuse is square root of x squared plus 1. So what is secant theta? Secant theta is 1 over cosine theta, and cosine's adjacent over hypotenuse. So secant theta, it would be hypotenuse over adjacent, so that's going to equal square root of x squared plus 1. So then all the secant thetas will be square root of x squared plus 1. That's 1/2 square root of x squared plus 1 times x plus 1/2 natural log absolute value of square root of x squared plus 1 plus x plus c. Okay, so you always have to use this right triangle trick after doing the trig substitution and working it out. So suppose I have 1 minus x squared. Well, then this one is going to look more like the trig identity 1 minus, it doesn't really matter which one you do, 1 minus sine squared x equals cosine squared x. Right? And do I like this one better? Sorry, theta. Let's use theta here, so it's much easier. So here I'm going to say, well, if x were equal to sine theta, dx would then equal to cosine theta d theta. So then when I do this integral, I'm going to do the square root of 1 minus x squared, which is sine, so sine squared theta, and then dx I replace with cosine theta d theta. That equals the integral square root of cosine squared theta cosine theta d theta, or this is just the integral of cosine squared theta d theta. Now what's the trick that we do here is this is use the cosine squared x, is use the double angle identity. So this is going to be 1/2 theta. Derivative sine is cosine, so it's going to be 1/2 sine 2 theta, then times 1/2 because reversing chain rule. So this is 1/2 theta plus 1/4 sine of 2 theta plus c. Now this sine of 2 theta, the thing is I only know what a theta is, and I don't know what a 2 theta is, so I can use one identity. Sine of 2 theta I can be written as 2 sine theta cosine theta. Okay, so this would be 1/2 theta now plus 1/2 sine theta cosine theta plus c. And again, my goal is to put everything back in terms of theta, or like in terms of x, sorry. So my answers are in, so theta, so if x is equal to sine theta, first I need to figure out what theta is. So like my sine theta is x here. Theta is just equal to inverse sine of x. So that I can't get around. That's what I have to do there. But for the cosine theta, you could write it as cosine of sine inverse of x, but that's not really like that elegant of an answer, or very simplified. So theta, I know sine of theta is x. So sine is opposite over hypotenuse. So that's x, and that's 1. That means by Pythagorean theorem, this side is 1 minus x squared. And so that means cosine theta is adjacent over hypotenuse. It's the square root of 1 minus x squared, like that. And so then now I can complete this. This is going to be 1/2 sine inverse of x plus 1/2 x square root of 1 minus x squared plus c. Okay. And then let's look at this one. Wait, yeah, this is x squared minus 1. So thanks for watching. If you enjoyed this video, I go through a lot more of these exact kinds of problems with much longer videos on my website. It's entirely free. Check out the link in the description below.